So this is a demo of a PoC trying another approach of using IDE diagnostic warnings and errors within Duo workflow. So last time I showed a screen recording of a new IDE diagnostics tool, which allowed the model to proactively call the tool and find out the validity of a given file. This time I'm trying a new approach of integrating the diagnostics more directly into the existing workflow tools. So this workflow is completed now. You can see that I asked for an add function that sums two numbers, which has been created. However, the variable names look a little unusual. They're prefixed with some kind of like Hungarian notation or something. At first glance, this seems unwanted in a TypeScript project, but if I edit one of these variable names, you can see that in this demo project, there's actually a ESLint rule enabled that enforces this naming convention. So it's quite an unusual naming style for a TypeScript project, so how did Duo Workflow manage to get that correct? So if we dive into the logs, we'll be able to see what went down. And you can see at some stage we got a write file action. You can see here the model told us to write this code, which does not have the prefix naming style on the variables. So we write the file. The very next thing that happens is the write file tool asks the IDE if there's any diagnostics warnings or errors. We get back this structured block of errors, message, the range, all of that kind of thing. In this case, they're provided by the ESLint extension I have installed in VS Code. So then, instead of just returning the string file written successfully, like the tool previously did, we now get these diagnostic errors, format them, and then include them in that tool response, along with a little instruction that it should actually do something about that. And then scrolling a little further, we get another write file action, and this time the changes are applied. We check again for the diagnostics, and there's nothing, so we know we're good to go. So what's nice about this approach compared to building a dedicated tool for getting diagnostics is we don't have to prompt the model into remembering to call the tool and check its work. The errors are automatically surfaced every time it writes a file, and the error should be directly associated with the tool call that it's just done. And additionally, since the errors are returned on the write file tool response, there's no extra round trip of a whole nother tool call. So taking this further, in the IDE, when it highlights diagnostic issues, there's a code actions UI, and you can see various quick fix commands, including our own upcoming fix with GeoChat. Clicking it will automatically fix the issue. Not all diagnostics will come with auto fixes. In this case, the author of the specific ESLint rule built their own fix action into it, but many diagnostics are auto fixable. So I used an ESLint error for this demo because it's easy to understand and get the workflow to generate code with problems to show. But this will work with any diagnostic in the editor, lint issues, formatting, syntax errors, missing imports, or if the model hallucinates some API on third-party code. So I figured, why tell the model about the error and expect it to come up with a fix if we can just apply the fix automatically? So that's what I did next. So here's a new workflow. I used the same prompt, but it's running on the next iteration of this code. And again, if we look at the logs to see what's going on, we once again received a run write file action. The code that the model generated did not have the prefixing on the variables as we expect. We get the diagnostics again, it's the same set of errors, but this time we attempt to automatically fix these diagnostics using the IDE. We get the diagnostics again, and there's no errors remaining at the end, so we can return a successful result. Now the fix code executes literally the same action that the VS Code UI does. So the quality of the auto-applied fix depends on the particular error and the available resolution. And because there's often many quick fix actions for any one diagnostic, I've selected the fix that's marked as preferred. So for this ESLint error, the fix that comes from the actual lint rule itself is the preferred one. It means that we're less likely to get in a match, that there's not always a preferred one. But when we do get a match, it should reliably resolve the problem. Now I glossed over it before in the logs, but while testing I noticed that sometimes the diagnostics we get from the workflow are formatting issues, so I added some code to trigger an auto format of the document using the IDE. This demo project is using Prettier for formatting, so that's what VS Code would have used under the hood when it tried to format the document. But it should work with whichever setup the user has configured in VS Code. Again, it's the same as if you ran the command directly from the IDE UI. So this cuts down on the issues that we have to resolve. So far, all of this has been inside the write file tool, but arguably the edit file tool is going to be more commonly used, and adding these changes there is possible, but it will take a little bit of extra care. So for example, with the auto formatting I was just talking about, not all projects use tooling like Prettier, and users might not appreciate their existing code being auto formatted by Duo. In this particular case, VS Code allows formatting a specific range of the document, so it could be set up to figure out the format of the range of the edit and only format that section. Similarly, for diagnostics, the existing code might be filled with warnings and errors already. We don't want Duo to start fixing other random things in the code or getting led astray by problems that are unrelated to the task at hand. This also isn't properly working, but the idea would be to fetch the diagnostics before we edit the file, and then fetch them again afterwards, and then compare and see which diagnostics are new. So some complexity to get this working, because when you edit the file, all of the line numbers change, and so it's kind of hard to compare the diagnostics, but it's probably possible. There's also the issue that if you make an edit somewhere in the code, it might cause a diagnostic error outside of that range that you're editing within. So for example, if I renamed a variable up here, then it might break something further down. So maybe that's desirable to fix diagnostics outside of the editable range, or maybe not. It's a bit murky. We could just limit the fixes that we automatically do to stay within that range of code that Duo has actually edited. Yeah, I'm not too sure what's best. But yeah, this is pretty neat. Worth mentioning, the big downside here is that all of this is achieved by using the available VS Code APIs. So we'll need to re-implement and maintain this in all of our other supported IDEs, JetBrains, Eclipse, Visual Studio, and they might not all have equivalent capabilities. So it's probably worth thinking of this as a progressive enhancement rather than some core functionality of the tools. There may be ways to achieve some of this stuff with the standard language server protocols, but I mostly focused on just getting it running and didn't look too far into that side of things. So yeah, overall a few nice improvements we could consider integrating into the tools: auto-formatting code, auto-fixing errors, and surfacing anything we couldn't automatically resolve in the tool response. Let me know what you think.